Laplace Theorem 3, question 2. Determine the Laplace of 1 minus cos 2t over t. First, we need to do a limit test. This is to determine if in the limit when t tends to 0, it converges to a value. So limit t tends to 0 of 1 minus cos 2t over t. And that will be 1 when t equal to 0, so you get 1 minus cos of 0 is 1. And 1 minus 1 is 0 over t equal to 0, 0, and that's 0 over 0, which is indeterminate case. In other words, we need to apply, in this case, L'Hopital's rule. And in this case, we apply limit when t tends to 0 for 1 minus cos 2t over t, and that equal to limit t tends to 0. We need to differentiate now. We differentiate 1, you get 0. Differentiate minus cos 2t, you get 2 sine 2t over 1, because if you differentiate t, you get 1. T equal to 0. Sine of 0 is 0, and 1, so 0 over 1 is 0. So limit doesn't exist. And now we're going to apply the theorem 3 to Laplace. And before we do that, we have to do Laplace of 1 minus cos 2t. 1 is a constant. If you look on the table on the right, a is a constant, a over s, 1 over s, because a is 1. So you get 1 over s. And cos 2t will be s over s squared. A is 2, so that'll be plus 2 squared, which is 4. And now we need to integrate. So we're integrating from sigma equals s to infinity. We are replacing s with sigma, and then we're going to integrate d sigma. Integral of 1 over x is ln x. Integral of 1 over sigma is ln sigma, minus the integral of sigma over sigma squared plus 4 is, this is how I've done it on the left, top left. I have ln sigma squared plus 4 from the boundary of infinity and sigma equals to s. Equal to, we take a half out of that equation, so I have square bracket 2 ln sigma minus ln sigma squared plus 4 close bracket infinity and sigma equals to s. And we have the half. The 2 goes to sigma squared, so sigma squared over, because of minus, sigma squared plus 4, using the logarithm rule, the boundary sigma equals to s to infinity. And then if sigma tends to infinity, then ln sigma squared over sigma plus 4 would tend to ln 1, which is 0. You can see I've done it on the left top. And therefore we can write a half the ln infinity squared over infinity squared plus 4. Hence that is why it's 1 minus ln s squared over s squared plus 4. And that would be a half, open bracket, 0 minus ln s squared over s squared plus 4. Now we can write a Laplace of cos 2t over t, which is minus a half ln s squared over s squared plus 4. You take the minus to the power, so ln s squared over s squared plus 4 all to power minus a half using logarithm rule. And you're going to get ln s squared plus 4 over s squared square root. And that's the Laplace of 1 minus cos 2t over t.